adding and subtracting fractions in 5th grade, we're building off prior knowledge of 3rd and 4th grade, which is adding like denominators. So they'll get a problem like 1/4 plus 1/4 plus 1/4, knowing that these are all the same size piece, the same size denominator. They can add the amount, which is the numerator, and get an answer of 3/4. Now in 5th grade we get more challenging. We throw at them different size pieces, and I like to point out to them, when you have a half and a fourth, this is like adding a foot and an inch. So these are two different values. So we wouldn't simply add these together and get an answer of 2/6. So we'll talk about why that does not make sense here in a minute, but just a visual representation of what problem this is. You have 1/2 plus 1/4. So you would have 1/4 plus 1/2, and this would be a 5th grade problem. So the first thing we need to do is find we need to find like denominators using equivalent fractions. So with this one's pretty simple. The kids get this. We have 1/2, and 1/2, if we just half this, we just turn that 1/2 into 2/4. So now you have 2/4 plus 1/4, and look at that, we just converted this to a 3rd or 4th grade problem, and this is now 3/4. So they don't have to do anything like, multiplying the denominators or anything like that to find a common. They can just use their number sense and say, okay, 2/4 plus 1/2 is the same thing as 2/4. I'm going to add that to 1/4 and get 3/4. Now going back to that common mistake here, now this is where number sense plays a huge part in fractions and be able to check their work, or at least getting to the closest to the right answer, is 1/2 plus 1/4, and I'll see it equals 2/6, which we know it's not 2/6. They should be thinking this: if I have 1/2 and I'm going to add to that, in fact I'm going to add another 1/4 to that, and my answer is 2/6, well 2/6 is smaller than 1/2. This should be danger zone. This answer does not make sense, and that's something that's so important in math that I want these students to take away. That if you have a half and you're adding something to that, check your answer and it's not even a half, something's not right with this. So again, it'd be 2/4 plus 1/4 equals 3/4. Alright, and we have 1/3 plus 2/5. This is a little more challenging, where you have to change both denominators here, unlike this one previous where you just had to change the half to a fourth. Here we need to change both. First strategy I like to show them is you can do 1/3 and you can find equivalent fractions by doing a pattern. So we can take the numerator and count by 1, so you can 1, 2, 3, 4, 5, and then you can count by 3s down at the bottom: 3, 6, 9, 12, 15. So these are all equivalent fractions. These are all the same. So that's one way. So 5/15 and then 2/5. So you have 2/5 would be 2, 4, 6, 5, 10, 15. And they can see here, okay, 2/5 is the same thing as 6/15. 1/3 is the same thing as 5/15. So my new problem is 5/15 plus 6/15, and that's going to be 11/15. And they can do like a number sense check here. They say, okay, I have a 1/3, that's a little smaller than a half, and I have a 2/5, which is a little smaller than a half. So if I have something a little smaller than a half plus something a little smaller than a half, it's probably going to be a little bit smaller than 1/2. So that's that number sense, and we talk about this daily. We check our problems like this, just thinking like that. And 11/15 does make sense. It's a little smaller than 1/2. You're actually 4/15 away from 1/2, so it's not that much. So this answer would be a good answer here. And that's one way of finding equivalent fractions, would be using this strategy here, which I call the skip count strategy, whatever, just the continual finding a pattern. The other strategy that I alluded to is multiplying the denominators together. So we do that as well. It's just, I give them different strategies, and whatever one that they grab onto, and whatever one just makes sense at the time, because it's just this one here I'm about to show you doesn't always make sense to use, because like on this example here, you don't need to make this an eighth. You don't need to turn this, you don't need to do 2 times 4 equals 8 and get 8s and change everything to 8s. In fact, you just need to change this 1 right here. So this was, that strategy, it actually wouldn't be as efficient So just giving us a bunch of strategies. So anyways, 1/3 plus 2/5. Another strategy is, okay, we can multiply our denominators here, 3 times 5, and this will give us a 15, so we know a common denominator for both of these will be 15. And then you go into the process of, okay, so to get 15 over here, we times this by a 3, and we need to times the top part by a 3. And I point out to them here that 3/3 is equal to 1 whole, and whenever you multiply something by 1 whole, you're going to get the same value. So 5 times 3 is 15, 2 times 3 is 6, so there's where we get 6/15 right there, timesing it by 3 over 3. And over here, to get 15, we times this by 5. I'm running out of room over here, but we times this by 5 over 5. And 5 over 5, I point out to them that that is also 1 whole. So when you times it by 1 whole, or 5 over 5, you're going to get 5/15. So now you have 5/15 plus 6/15 equals 11/15, which matches up with our answer here. So that's two different strategies to find equivalent fractions that equal 11/15. And again, I don't require one way or the other, and I definitely do, though, want them to check to see if their answer makes sense by just thinking of 1/3 plus 2/5 should equal something a little bit smaller than 1 whole. Now finally, we have a subtraction problem. Here again, now I will point out it wouldn't not be the most efficient way to turn these both into 50ths, so I'm not going to do the 5 times 10 strategy and get 50ths. It makes more sense to me here that if this is a 10th, I could change 3/5 into 6/10, either by just timesing it by 2 over 2, which is 1 whole, or doing the pattern 3, 6, 5, 10. Either way, I've just changed this problem to 6/10 minus 1/10, and I get 5/10. And I can check, I can say, okay, 3/5 is a little more than a half, and I'm going to subtract this small piece here, this 1/10. If I subtract from that, it should be around a half or so, somewhere in that in-between spot, and right there, it is a half, it's 5/10. So there's just a brief overview of adding and subtracting fractions with unlike denominators in the 5th grade.